Hello everyone. In this video, let me give you a few more examples of recursive functions. Okay, so let's read the first question that we plan to do. This function finds the value of a raised to b. Now you might say that we already have the POW function, right, in the math module. So why do we need to do this? Okay, you're right that we do have it, but here we are just learning how to write our own recursive functions. What's the idea behind it? So I just took this as an example. Okay, so now what do I mean by a raised to b? Suppose you have 5 raised to 3. What does 5 raised to 3 mean? I want to do 5 into 5 into 5. Correct? Can I say I actually want to do 5 into 5 raised to 2? Or can I say I want to do 5 into 5 into 5 raised to 1? Okay. Or can I say I want to do 5 into 5 into 5 into 5 raised to 0. Okay, so which means, can you see, I am planning to call the power function once. I am planning to call the power function once again, and I'm planning to call the power function once again. So I can make it a recursive function. So let me just try writing this program for you, and then we will see how the whole thing is going to run. Okay, and I have written the lines already. I will just explain to you what I mean by this. Okay, if I want to find a raised to b, what should the parameters of the function be? A and b. So I have written a and b. Okay, what is the base case here? When did you want to stop? When the exponent becomes 0, you want to stop. Right here, look here, last line. When you write 5 raised to 0, I know 5 raised to 0 is nothing but 1. So when you get the exponent as 0, you want to stop. So I wrote, if b is equal to 0, you stop. But in all the other cases, when b was not 0, when the second parameter, now in the first case here, what is the parameter? 3. When it is 3, what does it mean? It's 5, which is a, into, you call the power function again, didn't you write 5, into, and you call the power function again, but instead of 3, now you send 2. Isn't that b minus 1? So the whole idea is, you are going to recursively call the power function over and over again as long as the second parameter doesn't become 0. The minute the second parameter becomes 0, I have met my base case and I stop. Otherwise, let me tell you one thing. What is 5 raised to 10? Isn't it 5 multiplied by 5 raised to 9? What is 5 raised to 9? Isn't it 5 multiplied by 5 raised to 8? And that's exactly what I'm planning to do here. A into, that is 5 into power of 5 raised to 1 less than the value of b. So 5 raised to 9 would be written as 5 into 5 raised to 8. And that's exactly what is happening here. Let's just run the program and see, are we getting it according to our requirement? It's asking me for the base and the exponent. So let's say I write 5, or let's make it 2 so we know the answers faster. And let's make this as 5. 2 raised to 5 is 32. So the answer is 32. Is that clear? So how do you think about recursion? First, you see what has to be done. Based on that, form your base case, because that is important. Once you form your base case, just put it into the function. So now I didn't have to write any loop or anything. I was just calling the function from the function itself until it reached the base case. Is that clear? Okay, let me just give you another example. Now this says to display the nth element in a Fibonacci series. Now just to remind you what a Fibonacci series was, okay? The first two terms of the Fibonacci series is 0 and 1. from the second term onwards, it was just the summation of the previous two. So this is going to be 0 plus 1, giving me 1. Next term is going to be 1 plus 1, giving me 2. Next term is going to be 1 plus 2, giving me 3. Next, it's going to be 2 plus 3, giving me 5. Next, it's going to be 3 plus 5, giving me 8. And this can go on because it's an infinite series actually. Okay, so now tell me, now what could be our base case? If n's value is 1, that means if I want only the first term of the Fibonacci series, then obviously the answer is 0. But if n's value is 2, I want to find the second term of the Fibonacci series. That means my answer is 1. But if n's value is 3, can I say it's the summation of the second element plus the first element? Correct? That means Fibo of 3 will give me, is going to be calculated as, let's assume Fibo is the name of my function, okay? So Fibo of 3 is going to be calculated as Fibo of 3 minus 1 plus Fibo of 3 minus 2, correct? The previous two elements. Okay, let's just look at the programming lines here. I have just written the program for you so things become easy and we don't waste time, but explanation is already done. Okay, you want to find the nth term of the Fibonacci series. If n given is 1, you know the first term is 0. If n given is 2, you know the second term is 1. If n given is anything other than 0, 1 and 2, then what did I say? It's the summation of the previous two terms. So if n is 4, it's the summation of the third term and the second term. How do you get to third term? Fibo of n minus 1. And how do you get to the second term? Fibo of n minus 2. So Fibonacci of 5, which means fifth term, would be Fibonacci of 4 plus the Fibonacci of 3. Correct? So this is not, children, this is not generating the Fibonacci series. It is just giving me a particular term of the Fibonacci series. Let me just run the program here. And let's say the value of n is 5. I want the fifth term of the Fibonacci series. Let me look at this example here. 0 is the first term, 1 is the second term, third term, fourth term, fifth term is 3. So let's see, am I getting the answer as 3? Yes, it's giving me the answer as 3. Let me run the program once again. And let's say I want the seventh term of the Fibonacci series. You can see my seventh term is number 8. So here also I'm using recursion. Now why recursion? Because every number is the summation of the previous two numbers. So call the Fibonacci series once again to generate the terms. Now if you look here, you must have done this using iteration also, but there we had first and second, and then we displayed it, and then we had swapping of the numbers and all those kind of concepts. Here we don't need to do that at all. Just call it once again, and it's basically the formula. I'm just writing the formula. Fibonacci series of the nth term is nothing but n minus 2 plus n minus 1. That's the exact thing I'm writing. But suppose you wanted to generate or display the Fibonacci series, then what change can I do? I'm just showing it to you here. I will write the loop as for x in range. Okay, I want to generate Fibonacci series up to a range, okay? Not just give me that particular. So I write 1 comma n plus 1. 1 comma n, why n plus 1? Because if I say 5, I don't want it to stop at 4. I want it to stop at 5. Okay. And here you call the the Fibonacci function. So I write Fibo in bracket the value of x. Now understand this carefully. What is initially x? 1. So it's going to call Fibo of 1. That means n's value is 1. So what will it return? 0. So it will print 0. Next, x becomes 1. So it's going to call Fibo of 1. What will Fibo of, sorry, first it was 1, then it was 2. Fibo of 2. What will it return? 1. So it displays 1. Next, when in the loop x becomes 3, it's going to call Fibo of 3. So it's neither n is equal to 1 nor n is equal to 2. So what will it return? Fibo of 3 minus 2 plus Fibo of 2 minus 1. And we know that is 0 plus 1, which is 1. Okay, so let's just run this program and see the difference. So it's the function remained the same, only the calling has changed, because I'm not calling it once because I just don't want to know one term. I want to know the whole series. So I'm calling it in a loop. Okay, let me just run the program. It's asking me the value of n, let's say 5 or let's say 7. So it should give me this entire list that you see on screen. Okay, can you see 0, 1, 1, 2, 3, 5, 8? It's all on different lines. And we have learned if we need everything on the same line, just manipulate the end parameter. So I manipulate the end parameter, run it once again. It's asking me the value of n. Okay, now I said 5. Okay, so it's just showing me the first 5 terms. Is that clear? So did you understand the concept of recursion? So recursion means whenever you have a program, you have to see how you're going to break it down and at what case are you going to stop recursion. That is important. Here I have two base cases kind. N is 1 also and n is 2. So I could say those were not the recursive cases, those were the base cases. Otherwise, I am always going to find the 10th term as a summation of the 9th term as well as the 8th term. Is that clear? Okay. So hope you have understood the concept of recursion. Okay, thank you.